Hi everyone, I am J. Sathya Narayanan, Assistant Professor, Department of Costume Design and Fashion. Now we are going to see about water, water hardness, water softness, laundry soaps, manufacturing of soaps, etc. Water is an essential resource not only for drinking but also to keep the body clean, to wash dishes and clothes that we all know. In textile industry, the part of water plays the major role in cleaning of fibers, fabrics and during textile processing like in dyeing, etc. Most common, the garments get dirt by the environment in working area or while eating. On the time, we need water to clean the dirt away so as to clean the garments to clean and good. While washing the dirt clothes, we use soaps or detergents to catalyze the cleaning process. During that, we may notice the lather will produce, but this may differ from some water condition. That's because of presence of some chemicals, salts in water, which results the fabric does not clean properly. Hence, based on these properties, water is divided into two types, hard and soft water. The available water may be hard or soft. The hard water does not lather readily with soap. So, in laundry works, it is soft water that is the most important agent. The properties of water that makes it so useful for washing is the ability of water to adhere to the fabric so that it can penetrate into the fiber and wet it. The movement of this water molecule helps to remove non-greasy dirt so a fabric is partially cleaned by steeping and friction process. The salts and alkalis in hard water hinder the movement of particles, dust particles aggregate and larger ones resettle in the fabric. Cold water is the best solvent for albuminous, that is food protein matter. Hot water helps to melt and soften grease, but other cleaning agents are necessary to emulsify and remove greasy matter. In general, the solvent power of a liquid increases when its temperature is raised. Naturally occurring water is not absolutely pure. Its purity depends on the nature of the soil over or through which it has passed before being collected. Rainwater is the most pure, but even this contains substance absorbed from the impurity. Rainwater is ideal for laundry work, for it is soft. Water hardness. Most water, especially from chalky district, contains calcium and magnesium salts in solution, usually as sulfates of bicarbonates. These causes hardness. If the salt present in water is calcium or magnesium bicarbonate, the water has temporary hardness, which can be removed by heat without chemicals. The bicarbonates occur because of the action of carbonic acid in water or insoluble calcium carbonate. The acid dissolves the latter substance and holds it in the solution. By boiling, the carbon dioxide is driven off and insoluble calcium carbonate is precipitated as chalk. The water has been softened. All other compounds of calcium and magnesium, namely sulfates, chlorides and nitrates, cause permanent hardness. These salts are soluble in pure water and make this kind of hardness more persistent. It can only be removed by distillation, which is impracticable for laundry or by the use of chemicals. Hard water is not only bad for laundry, it is also harder to wash dishes, clothes, to bath, shave, cook and clean. The impurities that causes hardness in water are harmful both while manufacturing and washing fabric. During fabrication, water impurities deposited on the fabric detract from their finish and appearance. In washing, the lime and magnesium react with soap to make a curd-like substance called scum, which has no cleaning power. Larger quantities of soap has to be used to produce lather. Other chemicals and bleaches must also often be used. For laundry purposes, the hardness of water is measured in degree. If water contains an amount of hardening substance equivalent to 1 gram, that is 0.065 gram of calcium carbonate in 1 gallon, that is 4.6 liters of pure water, it has 1 degree of hardness. Soft water has less than 3 degree of hardness. Each grain of calcium carbonate in water requires 10 grains of soap to produce lather. Water softening. Both temporary and permanent hardness can be removed. by using soda removes both kind of hardness and can be used at home. For large scale softening, a combination of lime and soda or a water softening plant attached to the household supply can be used. The most common softening plant is a geolite, which also removes permanent and temporary hardness. Soda is inexpensive and easy to use, making it ideal for softening water in the home. Chalk is precipitated and only harmless salts remains in the water. About 2 grains of soda are needed per degree of hardness to soften 1 gallon of water. However, it is a chemical and it acts by producing a chemical change in the water. Two facts must be borne in mind. The first one is the action is not immediate. The speed at which water is softened by soda depends upon the temperature of the water. Boiling water softens in a few seconds, while cold water takes as long as an hour. Second thing is no more soda. Excess soda will hinder the cleaning properties of soap, may also damage certain fabrics. Some other softening agents are soap, caustic soda, ammonia and borax. Soap combines with the water hardening substance. However, this happens before a satisfactory lather can be formed. Also, soap is an expensive softening agent compared with soda. Caustic soda is not used in the home on account of its strength. It removes temporary hardness but reduces permanent hardness slightly. Solution of ammonia are used when fabric may be harmed by soda. However, excess ammonia may destroy the luster of rayon, discolor and injure animal fabrics and loosen the dyes of colored particles. As it is not possible to be certain of the quality to be used, ammonia is not a very practical softener. Borax does not harm fabric if left in water. It is useful for water containing over 20 degrees of hardness. In practice, borax is usually used to reduce the alkalinity of a soap solution rather than the water, for instance when washing babies' clothes. Geolite water softeners. A geolite plant attached to household water supply is a popular means of water softening which removes both temporary and permanent hardness. Discovered by Robert Gans, which works on the chemical principle of base or ion exchange. It is a chemical process. Zeolites are minerals consist of hydrated aluminum silicates of sodium, potassium, calcium and barium, which has the property to exchange its sodium or other base for another. Since sodium salts do not precipitate out on heating or form soap curls, the water is soft. As the water gets softened, the geolite becomes depleted, having given up all its sodium. However, a geolite can exchange its base again and take back sodium in place of calcium and magnesium in a process called regeneration. Depends on the amount of water which passes through the water softener. A domestic appliance can operate for several days without the need of regeneration. When the geolite finally deteriorates, it has to be replaced with fresh geolite. Geolite water softeners for domestic use are either connected to the main water supply or fixed to a water tap. In the latter case, the appliance is a portal type which can be removed from one tap to another. When installing on the main water supply, separate plumbing may be provided to flushes and taps where soft water is not needed. A main water softener does have some disadvantage. Through it tends to make drinking water somewhat unpalatable, although better for health. It makes water softer than is good for treating loose dyed fabrics. It necessitates a larger softener than is really necessary unless separate plumbing has been installed. Soap is the most widely used fabric cleaner. It is made by reacting natural oils or animal fats with sodium hydroxide or other strong alkali. The Asians might have stumbled on soap when melted animal fat or tallow got mixed with potash. This naturally occurring alkali is formed, for instance, in wood ash from fires. The Romans used soap as evidenced by written records and also a soap factory found in the ruins of Pompeii. There was a flourishing soap industry in Italy, Spain and France in the Middle Ages. Modern soap manufacturing based on chemical process can be traced to the 19th century. Manufacturing of soap. Soap is first made in molten form and then shaped into different sorts of finished products. Hard soaps, toilet soaps, powder, flakes, etc. Most soap today is made by full boiled process. In the first step is called emulsification and saponification. The natural fats are melted. The impurities allowed to settle and the clear fats pumped into kettles and heated with an open steam coil. A 10 to 15% of solution of caustic soda is added. The mixture is further heated by steam. The reaction mass now contains soap, glycerin, excess alkali, water and organic impurities. In the next step, salt is added to the mass. This makes the thick soap rise to the top. The liquid underneath is a mixture of salt, glycerin and unused alkali called spent lye. The steam is now turned off. The soap curd which rises to the surface is allowed to collect for a while. Then the spent lye below is drawn off and glycerin recovered from it. The soap is boiled with water or steam to make it into a paste again. The soapy layer will still contain a certain amount of unsaponified fat, so it is boiled again with more soda to complete the saponification. The mixture is allowed to settle and again the spent lye sinks to the bottom. It contains excess alkali and a small amount of glycerin and salt left from the last process. It is used with fresh alkali for the next soap making. After more boiling with water and steam and letting it stand, 4 layers will separate out. The top layer of 4 is skimmed off and the next soap layer below tapped off of the kettle by mechanical means. The third layer, known as niger, consists of impure dark colored soap solution and the bottom layer is alkaline liquid. The neat hard soap is mixed with sodium silicate carbonate solution not exceeding 4.5%. Coloring matter and scents may also be added. After through mixing, the soap is run into cooling frames. Cooling may range from a few hours to 5 days, depending on the type of cooling frame used. The cooled soap in the form of block is cut by machine into slabs and into bars and tablets and stamped. An alternate way of making soap is the cold process. The equipment needed is less expensive and the process itself is simpler and quicker. Coconut or palm kernel oil is reacted with caustic soda in suitable proportion. The mixture is stirred well over about 24 hours, during which the heat of the chemical reaction prevents it from hardening. The soap produced is hardened, contains glycerins and some free caustic soda. It lathers well in both hot and cold water. It is soluble in salt water, making it useful as marine. Composition of soap. Soap is sodium salts of fatty acids. The source of this acid is animal, that is tallow, grease, pollen, and vegetable, that is coconut, cotton seed, linen seed, olive, soya bean, palm oil, etc. fats. The chief alkalis used are caustic soda and caustic potash. All soaps contain water but not more than 20% in good soaps. Additives are also added to give soap specific properties. Naphtha and little mineral oil such as paraffin oil may be added to help in its cleansing properties and in the removal of grease. Rexin and naphthenic acid obtained from petroleum may also be used to improve the effectiveness of soap. Their presence makes the soap yellow and translucent, and since they are cheap, the soap can be sold as less unit cost. However, resin has less cleaning power than soap and can also discolor white articles, especially when combined with calcium from hot water. Other additives including disinfectants such as carbolic solvents and substances used for filling such as sodium silicate and sodium carbonate. Example, washing soda and phosphates. Filling also includes certain colloidal clays, colloidal organic matter and other cleaning powders. They act both as detergents and as mechanical aids in cleaning. In satin laundry soap, Care should be used as many kinds of soap can be quite harmful to clothes. For example, soap used to clean wool or silk should be free from alkali. Even 1% alkali is disastrous on cleaning silk. The following criteria may be used. Soap should be of clear, bright color as dark colored soap may contain impurities. The soap should feel firm when pressed. If it feels soft, it may contain excess water and will be wasteful in use. Many hard soaps, especially cheap makes, on the other hand, contains fillers like sodium silicate to disguise the low percentage of soap. Good laundry soaps dries with a firm and speckled surface. Soaps that develop white crystal should not be used, as this shown the presence of harmful excess alkali. A rough and ready test of good oil soap is to break a bar across the knee, examine the fracture and taste it. The fracture should be granular, not striated, and it should taste mild, not sharp to the tongue. Yeah, students, till now we have seen about water hardness and water softness, laundry soaps, soap manufacturing, etc. I will see you on another video. Thank you.